Okay, so in this second example involving Charles' law, again, this is the relationship between volume and temperature. It's very straightforward. Remember that volume and temperature are directly proportional, so that means that if one goes up, the other goes up. So let's take a look at this problem. When 5 liters of carbon monoxide gas at a temperature of 50 degrees Celsius is transferred to a 2.5 liter flask, the temperature decreases. What is the temperature at this new volume? Okay, so in this case, I am given 2 volumes, and I'm given 1 temperature. So I'm going to set up the problem the same way. So I'm going to write this one out. So I've got V1 over V2 equals T1 over T2. Now, again, I'm going to list off everything I know. I know that V1 is equal to 5.0 liters. I know my V2 is equal to 2.5 liters. I know my T1 is 50 degrees Celsius, but I don't leave it in Celsius. I make sure to add 273 to get into kelvins. Oops, sorry about that. Okay, and then my T2 is what I'm solving for. How do I know? It says, what is the temperature? So that's what I'm solving for. So now I just plug my numbers in. Okay, so my V1 is 5. My V2 is 2.5. My T1 is 323. And my T2 is what I'm solving for. Now, before I even plug this into the calculator, remember, you can always double check yourself and see if your answer makes sense before you even get there. So, what happened to our volume? Well, our volume went from 5 liters to 2.5 liters, which means that it went down. Since volume and temperature are directly proportional, that means our temperature should go down as well. So, let's pull out our handy dandy calculator and see if that's truly the case. So, again, I'm going to cross multiply. I'm going to take my 2.5 and I'm going to multiply by my 323. Okay, so that gives me 807.5, and then I divide by the thing that's going to be multiplied by the variable, which is 5.0. So I divide 5, and I get 161.5. So our answer here is 162 Kelvin. Why did I round it that way? Because I only need 3 digits. I start counting with the first non-zero, which is the 1. So 1, 6, and then I round it up. So my temperature started at 323 and it went down to 162. Does that make sense? Yes, it does. Since my volume was halved, my temperature had better be halved. And that's a second example of how to do a volume-temperature relationship problem.